Let's first observe a function. Say f of x equals 1 over x. And to graph it, here's the y-axis, and here's the x-axis. And the graph might look like this. And here's another one. Okay, the question is, what's the limit of this function, 1 over x, as x approaches infinity? What does that will equal to? Well, let's just observe this graph for a bit. As x approaches a positive infinity, which means we start from this origin and it goes towards the right hand side on and on, never stop. So that's why we use this infinity. And let's choose some points here. From here, and let's say here and here. We want to observe the corresponding x value and the y value. So in this case, this is the corresponding x value, and here is the corresponding y value. And for the second point, here is the x value, and here is the y value. And another one, here's the x value, here is the y value. And does that seems like as x approaches to the right hand side, goes right hand side, this y value goes down for a bit, and it seems like towards this origin, and this origin is 0. So if you choose another point and right here or right here goes on and on, this corresponding y value will still go down a bit and just seems like towards these 0. So we can say the limit of this function is 0. Same thing is for the limit of the function as x approaches a negative infinity. It's still 0. So let's say if we choose some number, I mean the points right here, the corresponding y value still goes towards this origin and is towards the 0. So the limit is 0. And talking about the limit, a lot of you guys might confuse a bit. Let me explain it this way. Let's draw a frying pan. I'll try my best to draw it. And here's the handle. Okay. And here's the lid. Okay. Now let's say we want to set the fire, and we put the oil in the frying pan and let it cook for a bit, like for 1 minute. And at the same time, you wash the vegetables and you forget to wet it all, so the vegetables comes with some water dripping. So in this time, the frying pan, the temperature is really high, and also for the oil, if you put the vegetable inside this frying pan, guess what will happen? The oil or even the vegetable will spitting out. So you want to quickly to put this lid above this frying pan to constrain to for this vegetable or oil from going outside. So this lid is just like the limit, right? It limits certain things from crossing it, or from just crossing it, and just to keep them in the certain bounds or certain boundaries. So back into this graph, 0 is just like the lid. So any value can approach this the 0 but never become 0 or cross it. So that's why we say the limit is 0. And since we observe this graph for this rational function, and we can get a formula, the general form for any rational function and r greater than 0, the limit of this rational function with the power of r as x approaches plus or minus this infinity equals 0. This is the formal definition. And you can think of it, use the direct substitution rule to replace this variable x with this infinity sign. Looks like that. Whenever you see this, the answer will be 0. And that's the definition for it.